Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about circles, normals and tangents to circles. So a few skills I need you super good at in order to do this particular skill. The first one is, suppose I gave you 2 points, x1, y1 and x2, y2, and I asked you to work out the gradient between those points. Pause the video and double check you remember how to calculate that. Okay, hopefully you will remember that is the height, the difference in y's, y2 subtract y1, divided by the width, which is x2 subtract x1, the difference in x's. And sometimes we remember the formula for the gradient of a straight line as the difference in y's divided by the difference in x's. I need you really familiar with that for this particular skill. The next thing we need to talk about is, do you remember what the condition is if two lines are perpendicular? If you had two straight lines, with general equation y is equal to m1 for some gradient x plus c1 for some y-intercept, and y equals m2x plus c2, if they're perpendicular, then what do you know is true? Pause the video and double check you can recall that fact. Well, we know that m1 multiplied by m2 is always -1, and we say that the gradients are the negative reciprocals of each other. So if two lines look like this and have a right angle between them, then we know the gradient of this line multiplied by the gradient of this line. If this line's gradient was, say, m1 and this one was m2, m1 multiplied by m2 would equal -1. Alright? Now one last thing I need you really familiar with as well is a way of defining a straight line. We did define a straight line, the general equation, as y is equal to mx plus c, okay, when you know the gradient and the y-intercept. What I want to ask you is, in straight lines, I gave you an alternative way of remembering it. If someone told you a point on the line and the gradient, can you remember the alternative form for the equation of a straight line? Well, for general points x and y, it is y subtract y1 is equal to m x subtract x1, where x1, y1 is a particular point known to you on the line and m is the gradient. This formula or equation here will always give you the equation of a straight line. Now it's time to talk about the new learning. We're talking about circles, normals and tangents, and what exactly are they. So let's do this in a diagram. So suppose you had a point in space, and let's decide to draw a circle around it as follows. Now suppose I also now wanted to draw a radius, a straight line going from the center to the edge of the circle, but have that radius going in that direction and in that direction. That the word for that's going to be diameter, and we'll see that idea in geometry. So just imagine I'm going to draw this diameter, but the line goes on forever. It doesn't just stop at the edge of the circle, so it looks something like that. So you'd agree with me that this point here acts like a radius, okay? The whole thing here is going to be the word diameter, but I've just got a straight line going through the circle like that. Now I want to draw at this point here, I want to draw a tangent to the circle. Remember, a tangent will just touch the circle. Let's have a look. Now, already the tangent and this line here seem like they've got a relationship. I'll come to that in a second, but can you see what I'm going to say about the green line and the blue line? Not only will there be a tangent there, but why don't I draw a tangent at the other place the green line and the circle intersect? So I'll draw another tangent there. Now, this piece of software I'm using can work out the angle between this line that is partially a radius, okay, this line here, and the blue line. And you'll be unsurprised to see that it is a 90-degree angle. The blue line and the green line are at right angles to each other. They are what's called perpendicular to each other. The gradient of the green line is the negative reciprocal of the gradient of the blue line. And the exact same is true down here as well. Now, we know the name of the blue line. It's called a tangent. And a line at 90 degrees to a tangent, it's going to be given a name. It's going to be called the normal. And remember, like the radius here is part of that normal, but we're going to call the whole line a normal. And the rule we've got here basically is that a tangent meets a radius at 90 degrees, and a line going through the radius meeting this tangent at this point, we're going to call it a normal. And I just want to prove to you for absolutely sure, so you're fully convinced, that it doesn't matter where these points are. So I'm just going to go like this and show you it doesn't matter at all where the points on the edge of the circle are. Okay, a radius and a tangent will always meet at 90 degrees, and we're going to call the green line henceforth what we call the normal. Okay, so let's formalize that idea. Here's a little annotated diagram with all that information. So we know that a tangent, a line that touches the circle, meets a radius at 90 degrees. And we call a straight line through the radius, meeting the tangent at that point, a normal line. Okay? And generally, very often, we know that point on the line, the coordinates there, and we'll know the center of the circle. So let me give you an example of a style of question we're going to be answering in a second. Suppose you knew the center of the circle and it was at 2, 3. And suppose you knew a point on the edge of the circle, 4, 4. You didn't know the length of the radius, okay, but somebody asked you to work out the equation of the normal line. How might you do that? It's a straight line. How would you do that? Or what information would you need? Well, you'd need the gradient of the normal, which I'll call m subscript n to stand for gradient of the normal, but you can find that by working out the gradient of the radius, can't you? The line segment, the radius. So you can do it here by working out the difference in y's divided by the difference in x's. And you would also need a point on the normal. Well, you've got 2 points on the normal, one here and one here. And you could plug those in as your x1, y1 into the formula y subtract y1 equals mn, I'm going to call it, x subtract x1. And you'd have your equation of the normal. How would you work out the equation of the tangent? Well, the great news is you can easily work out the gradient of the tangent, which I'll call mt, because it's perpendicular to the normal, so it's the negative reciprocal of that. And you know a point that the tangent goes through, only this one, it doesn't go through the center here, and you can use that using the exact same formula here in order to work out the equation of the tangent. And we're going to finish with a question where we work out the equation of the normal and the tangent to a circle. So pause the video and have a go if you think you can do this. Now part A is nice and easy. All we've got to do is verify that x is 4 and y is 4 lies on that circle. If we put in 4 for x and 4 for y and we get the answer 5, then we know it does. So all we've got to do is do 4 subtract 2 all squared, add 4 subtract 3 all squared, which will be 2 squared, which is 4, add 1 squared, which is 5, and that gives us 5. And therefore it lies on the circle, so we can state that and write down the reason. Now part B is where we're asked to work out the equation of the normal to this circle at this point. So let's use the picture I did on the last page. It's the very same circle with 0.44 and center 2, 3 from this information here. It's got radius 5, root 5 in fact, because it's what squares to 5. Okay, now there's our picture. How on earth are we going to work out the equation of the normal? We need its gradient and we need a point on the normal, and 4, 4 and 2, 3 satisfy both those, so we could use either. So let's start by working the gradient of the normal, which we're going to call m for gradient, subscript n to denote is for the normal. And we need to work out the gradient of this radius here, because that is the same as the gradient of the normal. They lie on the same in direction, even on the same line. So we're going to use the difference in y's divided by the difference in x's. So we're going to say it's 4 subtract 3, which is the height, 4 subtract 3, divided by 4 subtract 2, which is equal to a half if you work that out. So we've got the gradient of the normal. Now all we need is a point on the line. Well, we can use that one or that one, it doesn't matter. Let's just use that one there. And we can say therefore that y subtract y1, which is 4, is therefore equal to the gradient of the normal, which is a half, x subtract x1, which is 4. And there you go, we have got the equation of the normal. Now we can tidy this up if we really wanted to make y the subject, let's say. If we times both sides by 2, alright, of the equation, in order to just remove that half, if you wanted to, then you would get on the left hand side 2y subtract 8 is going to be equal to, that would just be 1, and 1 times that bracket would be x subtract 4. You could add 8 to both sides and get that, therefore that 2y is equal to x add 4. Divide both sides by 2 and you would get y is a half x add 2, and there's your equation of the normal. Let's go to the next page and work out the equation of the tangent. So let's go here to give us some space. Let's draw the picture again, and let's remind ourselves that we knew for a fact for part C, we knew that the gradient of the normal was equal to a half. Therefore, we know automatically the gradient of the tangent. The gradient of the tangent is its negative reciprocal. The reciprocal of this is 2. The negative reciprocal is therefore negative 2. And we also know a point that the tangent goes through, 4, 4. Don't be confused, it doesn't go through 2, 3, it goes through 4, 4. So we use the formula y subtract y1 is mt x subtract x1. And we just say therefore that y subtract 4 is negative 2 x subtract 4. We can multiply out that bracket if we want to get the following, and we could add 4 to both sides if we really wanted, and we would get ourselves the following, which someone might write the other way around like that. And there you go, we have done this question. Thanks loads for watching.